Okay, in these problems here today, you're graphing logarithmic functions. Now, logarithm functions we're going to need to make two tables when we see this. Okay, you'll see why here in a bit. Make one here, and then one here. Okay, now this is going to turn into an exponent equation, so you'll have to do the asymptote. So write a as y, and you also need to do it here. Asymptote is what that stands for. It's abbreviation. Okay, first we need to get rid of the logarithm. Now, after the base 5, you want to put that x in parentheses. Okay, and you're going to rewrite the equation out of logarithm form. So this x right here, whatever's in that parentheses, is going to come out here. And over here, you're going to have a power exponent expression. So 5 is your base, and whatever's over here, that's your power. Okay, base. B-A-S-E, power, P-O-W-E-R. So I write 5 down, I make a caret symbol, and I put y. Now, I'm used to having the y here and the x here, so you're going to write the inverse, okay? So when you write the inverse, you swap the x and the y, okay? Y goes here. And then now we switch it. And the y is by itself, so that's good. Now we just started. It's just a basic exponent function. I make a table for it. Now, I'm going to parenthesize this, okay, the base and the exponent. And 5 is bigger than 1 whole, so it's a growth. So that means when I do my table, I want to start with positive 2. And then go to the negatives after this. And then negative 10 will find our asymptote for us. Okay, so 5 to the power of 2 first. That's going to be 25. So if the positive second power is 25, the negative second power is just the reciprocal, so 1/25. Okay, 5 to the 1 power we should know is 5, and then that's 1/5, and then anything to the 0 power is 1. Okay, now plug in that negative 10. 5 caret negative 10. Yeah, it's pretty much 0. Okay, so on the asymptote, y is equal to 0. Now, do you have to make any adjustments to this table? You're not going to have to today, because the x is just the exponent. There's nothing added to the exponent, and then there's no operations outside, so that's good. But now, since I had to do an inverse on that, I need to go to this table and flip the values. So instead of 225, you're now going to have 25 and 2. Instead of 1, 5, you're going to have 5, 1. Instead of 0, 1, you're going to have 1, 0. And instead of negative 1, 1/5, you're going to have 1/5 for x, negative 1. You're just basically switching them. Then 1/25, then negative 2. Okay, asymptote y equals. Now it's not going to be y, though. It's going to be x. X equals 0. Okay, make that table, make that, go 0, negative 10. But now the asymptote, instead of y equals 0, it'll be x equals 0. So how do you set the asymptote? Well, 0 on x is right here, okay? So now you're labeling the x-axis, and this is the asymptote. You're essentially just tracing over the y-axis line. So now it'll be an up and down asymptote instead of a cross. Okay, so 25, 2. Well, on the x-axis, I got to make it to 25. So I go 5, 10, 15, 20, 25. So I go 25 up 2. You can still go by 1s on the y. 5, 1. So I go to 5, 1. 1, 0. So 1's here and then 0's here. Now, after you get those first 3 points, you're going to go out this way. Then you go up against the asymptote that way. Okay? Now, so that's your graph. Now I do want the domain and range. Now the all value now switches to the range. The range is now all, and your asymptote, which is x, and 0, okay, is your domain. But you got to put greater than or less than. Now if here's 0, looks like those are greater than, okay, all those values are greater than 0, so I put greater than. Okay, next problem. Y equals 1/4. Y equals log base 1/4 of x. So again, get the two tables set up. Okay. Okay, so we know we're gonna have asymptotes with these as well. Okay, asymptotes with those. Okay, now get rid of this logarithm. Okay, put a parentheses there. What's after the bit, whatever the log's base is. Remember, the base is 1/4. Okay, so you go x equals. And remember, this is the base you're going to use, and this is the power you are going to use. Now, since the base is a fraction, you're going to want to put a parentheses around the 1/4, and then make your caret, and then y. Okay. Now, we don't really like x as the dependent variable, so if I write the inverse, then I can deal with y the way I'm used to. So y equals 1/4 to the x power. Okay, put a parentheses around that and set up your table. So this is a decay now, because 1/4 is smaller than 1/2. Decay, the base of the exponent is smaller than 1/2. So now I would go -2, -1, 0, 1, 2, and then +10 discovers my asymptote. Okay. Okay, so I go parentheses 1ABC4 caret -2. Okay, that's 16. Reason why that's 16, because if you look here, if you have 1/4 to the -2nd, you can make it positive if these switch places. So 4 to the 2nd, 16, 1 to the 2nd's 1, and it'd be 16. Okay, so if that's 16, this is the 1/16. Okay, 1/4 to the -1. It's going to be 4, and then this is going to be 1/4. And then to that's going to be 1. Now if I put 10 in, 10 is just a random extreme number I pick. It's about 0. Okay, so in the asymptote, y equals 0. Now, it's important to look, you don't have anything added or subtracted to the exponent, and you don't have any operations outside the function. That's why you need to put a parentheses around the base in the exponent. You're going to have, when you have decay like a fraction, you're going to have to make an an inner parentheses for the fraction, and then an outer parentheses for the whole base power combination. Okay. All right, so then I flip it. I go 16, -2. 4, -1, 1, 0, 1/4, 1, 1/16, 2, and then you still got your asymptote 0, 10. Now the 0 is still the asymptote, but instead of it being y, it's now x. It's now a vertical asymptote. Okay, so I go x equals 0. X equals 0 is just right there. Okay. And it'll be up and down this time. It'll go through that 0 point. Okay, 0 just goes through it. So 16, -2. So I got to go 2, 4, 6, 8, 10, 12, 14, 16, and then 1, 2, -2. 4, 1, so 4, -1, 1, 0. Okay, it's right there. So I can see what's happening pretty much. Okay, so I go out this way. And here, all you do is you're getting closer and closer to the asymptote line. Okay, this way. So this way just took us extreme. This way you just get further. It should look like a fishing hook, but just in an inverted formation. Domain, range. Okay. All right, now the range is going to be all. Okay. And then it's going to be the domain where I put x with 0. And then all those values are on the x table are greater than 0. Not equal to. You'll never get equal to it, which is why I'm not putting it. Okay. Asymptotes you never get equal to. Okay, next one. Y equals log base 4 of x. Okay. Log base 4 of x. Okay, so we know we're going to need 2 tables. Going to need to know our asymptote on both these tables, because logarithm functions will be inverted into an exponent function. Put a parentheses, so we're going to have x equals, and remember, this is going to be an exponent expression, okay? It's a power expression. The 4 is the base, and then the y is my power. Okay, so I put 4 caret y. But now I don't like graphing functions. I'm used to having y as the dependent, x as the independent, so I invert it. That's why you'll have to do another table where the values are flipped. Okay, and y is by itself, so that's good. Okay, now you're going to want to parenthesize the base exponent. The 4 right there, that's bigger than 1, so that's going to be growth. So if it's growth, I want to start with the positives, then go to the negatives, and then negative 10 is what will give me my asymptote. So 4 to the power of 2. 4 times 4 is 16. If it's a negative 2, it'd be 1/16. 4 to the 1 power is 4, and then 1/4. 4 to the 0 is 1. Now if you insert a negative 10, you're going to get 0. Okay, now the asymptote, that would mean y is equal to the 0. That's why you put that last little part. You're not going to graph that point, but it tells you what the asymptote is. Okay, there's nothing added to x, so the x would stay, and there's no operations outside. Okay, now flip it. So 16 to 2, because that's actually the function there. I just wrote it so it'd be a little something I was more comfortable with. 4 to 1, 1 to 0, 1/4 to negative 1, and then 1/16, negative 2. Then it'll be 0, negative 10. Now the asymptote's still 0, but now it's under the x, so it's x equals 0. So on the x-axis, here's 0. Okay, so I make a line. Now it's straight up and down. Okay, because that's x equals 0. Okay, so 16, 2. Again, I'm going to have to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 16, 2, 4, 1, 1, 0. And then with the 1/4, all you do, negative 1, all you do is just get closer to the line, okay? Never actually crossing it. So you go this way, and then this way. Okay, we still need to do our domain and range. Now the range is the all, and the x equals 0. You're going to have x 0, okay? And looks to me like all points for the x, if you look at all those points before your 0, they're all greater than 0. Okay. Okay, last problem. Log has to have a base. If it doesn't, 10's the automatic. Okay, 10's the automatic base, and put a parentheses around that x. So now we know we're going to need 2 tables. Okay, and now we have to write this out of logarithm form. So whatever's after the base, in parentheses, the x, okay, put that here. Now I write a power. 10 is the base, y is the power. Okay, so 10 caret y, but then I quickly write the inverse so that the y becomes the independent variable. And there we go. Y is by itself, so we're ready to roll. Okay, now you need to get in the habit of parenthesizing the base exponent. Okay, so it's 10 to the x power. So 10 is greater than 1, so it's going to be another growth. Okay, so 2, 1, 0, negative 1, negative 2, and then negative 10 will kind of tell us what that asymptote is. We're also going to need the asymptote over here as well. Okay, so 10 to the power of 2, it's just same as 10 times itself, that's 100. So then this is going to be 1/100th. 10 to the first, it's going to be 10, and this is going to be 1/10. 10 to the 0 is going to be 1. Now if I take 10 caret and put negative 10 in for x, if you get scientific notation, that's the same as 0. Okay, so small the calculator wanted. So the asymptote, okay, y equals 0. Now you go flip it. So you have 100 to 2, 10 to 1, 1, 0, 1/10, -1, 1/100th, -2. Okay, and then it'll be 0, -10. Now 0 is still the asymptote, okay? The number doesn't change, but instead of it being y equal to 0, it will be x equal to 0. So 0 on the x is here, so I go right through that, x equals 0. Okay, to get to 100, let's go by 20s. 20, 40, 60, 80, 100. Okay, so 100 up 2, 10, 10's right here, up 1. Okay, and you can see how that's working. 1 is 0's here. Okay, so you're going to go up that way, and then here you just slide against the asymptote. You don't even really need to make those last 2 points. Okay, so domain and range. So now it's the range that is all, and then x equals 0. Just put 0, but you don't put equals 0. It's all numbers greater than 0.